Welcome back to Arxflix. Today, we're diving into a groundbreaking research paper titled Beyond Human Data: Scaling Self-Training for Problem-Solving with Language Models. This work explores the innovative ReSTEM method for improving language models like POMT, using model-generated data instead of relying predominantly on human-generated data. Fine-tuning language models on human data is often limited by the quantity and diversity of that data. This paper investigates whether self-training with feedback can reduce reliance on human data, especially in complex domains like mathematics and coding. The method they propose is called ReSTEM. Obtaining high-quality human data, especially for complex tasks like advanced math reasoning or coding, is resource-intensive and costly. Imagine if we could sidestep this bottleneck by using model-generated data. The key idea here is to use a model to generate training samples, which are then filtered and used to fine-tune the model itself. ReSTEM stands for Reinforced Self-Training using Expectation Maximization. It's a method that alternates between generating data, E step, and fine-tuning the model, M step. Here's how it works. Step 1. The language model generates multiple output samples for each input context. These are filtered using a binary feedback mechanism to ensure only high-quality samples are retained. Step 2. The model is then fine-tuned on these high-quality samples. This process is repeated multiple times to continually improve the model. The researchers tested ReSTEM on advanced mathematical reasoning benchmarks and coding tasks using POMT models. They found that ReSTEM scales favorably with model size, significantly outperforming models fine-tuned solely on human data. The performance gains were particularly notable in models fine-tuned on model-generated synthetic data, as evidenced by better test accuracy on both the math and apps datasets compared to human-generated data. ReSTEM allows models to generate their own training data, which can then be used to further fine-tune the model. This leads to substantial improvements in tasks that are typically resource-intensive to annotate by humans. On code generation tasks, for instance, most of the performance gains were realized in the first iteration of ReSTEM, with subsequent iterations leading to regression due to overfitting on the training data. This indicates the method's efficiency, but also highlights the need for careful iteration management. The study also explored the impact of ReSTEM on Pass-K and majority voting performance. These metrics help measure the diversity and correctness of the generated solutions. Pass-K measures the probability that at least one of the top K-generated solutions is correct. Here, ReSTEM fine-tuned models significantly outperform the base models. While multiple iterations of ReSTEM can sometimes lead to overfitting, especially with smaller datasets, the study finds that using larger models and more data can mitigate this issue. It's fascinating to see how the math dataset's test accuracy improves over iterations, though improvements start diminishing after a few repetitions. What makes ReSTEM particularly intriguing is its efficiency, even compared to human data. The study showed that even when comparing model-generated data to high-quality human data, ReSTEM still delivered superior performance. This finding underscores the potential of using scalable, model-generated synthetic data for fine-tuning language models, without depending heavily on human input. The real-world impact of ReSTEM was validated through rigorous testing on various benchmarks, including the Big Bench Hard Suite and mathematical problem-solving exams. These models not only matched, but sometimes outperformed models fine-tuned on human-generated data, especially in tasks requiring advanced reasoning and problem-solving. ReSTEM represents a significant leap forward in self-training language models, minimizing dependency on human-generated data and unlocking new potentials for scalability. This innovative approach can profoundly impact how we train and apply large language models in complex domains. That's a wrap on today's video. If you found this breakdown of ReSTEM helpful, hit the like button and subscribe for more deep dives into the latest research. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.